So we built a hierarchy. We've got professors, we've got different kinds of students, we've got MIT people, we've got ordinary people. We've seen some of the nice aspects of how that lets us isolate methods within particular class instances. Let's look at one more direction of building this hierarchy. In particular, to look at a class that can include instances of other classes within it. And here, staying with my theme of students, I'm going to create something called a gradebook. The idea is to build a data structure that can hold grades for students. And I want to gather together the data and procedures for dealing with them in a single structure so that users can manipulate them without knowing the internal details. So within a class or a gradebook instance, I'm going to have representations of students. I'm going to have representations of grades. I'm going to capture all of those instances of other classes inside of that structure. Let's look at some code and let's see what happens when we then use it. So here's my definition for grades as a class. And you notice the doc string. It says it's a mapping from students to a list of grades. And I want to show you what that means. As always, I'm going to start with how do I create an instance of a gradebook or grades, an empty gradebook. And I'm going to have two parts here. The first part is, inside that gradebook, I want a list of students. I want a list of the different students in the class. As we saw in an earlier example, I could do this with a set of lists, but I'd like to associate with the student a piece of information. So I'm similarly going to have an internal representation of the grades, and they are going to be represented as a dictionary because I'm going to use ID number to get a list of grades associated with each student. Let's look at that a little more carefully. I'm going to set up students as an instance name within an instance created here that's initially an empty list. When I want to add a student to my class, I'm going to first of all check to make sure that that student is not already in there. And then notice there's that little test where I'm going to raise a value error if in fact I've already got a version of the student in the class. But the second thing is notice how I do the add. Because students is a list, I simply append directly onto it, mutating that list to add in that student. Grades is a dictionary. And so notice when I add a student, what I do. I take the student, which is an instance of a class. I get out the procedure that is associated with it that gets out the ID name. I call it with the open-close paren. And that gives me now a spot in the dictionary. In fact, it's going to create a spot in the dictionary in this case. And into that, I store an empty list. The nice thing here is that my dictionary is going to be accessed by ID number. Separately, I'll have a list of students, and that will allow me to manipulate either of those depending on what information I want to get out. The last piece about this class, when I set up the initial instance, I'm going to say arbitrarily, because there's nothing in there, that this list or this collection is sorted. If there's nothing there, that's obviously true. When I add a new student to the class, because it's getting appended to the end of the list, I'm going to change that flag to false. And that'll be important if I ever want to get out a list of the students sorted by ID number. All right, there's the first part of grading the grades object, the grade book. Now, I want to add a grade in. I've got a student, I've got a new grade in this class. And remember, a student's going to have multiple grades because there are multiple quizzes. So how do I want to deal with that? Adding the grade is going to be fairly straightforward. Notice the format that I've got here. Because it's a dictionary, as I just did before, I'm going to take student, which is an instance, call the get ID number from that class on it. That gives me back an ID number. And I am then going to, in that spot, in grades, insert, let me rephrase that, add something. To say it a little bit better, doing that particular access gets me out from the dictionary a list of grades. It goes into the dictionary, pulls it out. Because it's a list of grades, I can add to the end, mutate in place. And that's great. It says for every student, I can add a new grade to their list. Notice I'm going to use my nice try method to do that, and simply it will work unless there is no entry in the dictionary for this student, in which case it's going to raise a key error saying that I've got a problem, and in that case, I'm going to explicitly raise a value error, printing out, here's the problem. Using that idea we had earlier on of trying something and then handling the exception when it comes up. I can add grades to the grade book. Finally, I might want to get out a list of grades for a student. And again, I'm going to use the try method with almost the same kind of indexing. Given the student, which is an instance, I call the class method for that type of instance to get out a particular ID number, and I go into grades, which is a dictionary, to retrieve that entry. The last thing I do we saw before, which is rather than returning it, I'm going to return a copy, which means I can do things on that without destroying the original set of grades. A safe thing to do. And again, as before, I'm going to run in case I hit an error, and if I get an error, meaning I can't get into the dictionary, I'm again going to raise my own value error telling me that the student was not in the grade book. And then finally, I might want to get a list of all the students in the grade book. And here's where I'm going to take advantage of that flag, which is if that flag for this instance is sorted is false, I'm going to go ahead and sort. Remember, it's a list, so I can do that in place. I'll set the flag to true. And then, in either case, having done that, I'm going to return a copy of the list of students. So I go into students, which is that list, and I return a copy, again, so I don't accidentally destroy the underlying list stored inside of the instance. What do I have here? I've got a data structure, a grade book. Inside of it, I have a set of classes. And notice how I'm storing them. I have a list of the students. Those are the classes. And I have associated with that a dictionary that by ID number lets me retrieve information about each student. Okay, let's see what happens if we were to try this out. So, I can create this. Now, I want to get out a report. How are students doing in my class? Here, I'm going to take advantage of the fact that I can get out all of the students. And if I go back a slide, remember, all students here gives me a copy of the list of all the students stored in that class. So if I go back forward, what am I going to do? I'm simply going to loop over that collection. And I'm going to use that method to get out that list so that I'm preserving the information hiding. I'm not directly going in and getting that list. And I'm going to loop over that. For every student in that list, I'm going to simply do a little computation. I'll set total to 0, number of grades to 0, and I'll run for every grade in the grades associated with that student. And notice the access there, right here, which is, again, I'm using the getter of get grades for that student to return the list of grades. And I just run through it, adding the grades up, increasing the number of grades I've got recorded. And then I'm going to just report the average, unless I have a divide by 0 error, in which case I will report something different. And I'm simply appending that onto that list that I'm growing. When I'm done with all of that, I'm just going to return it. And I'm going to do one unusual thing down here, which is because this is a big list of strings, I'm going to return it where I break this up by inserting a carriage return in between each one of those strings. And that's what that join operation does that we saw earlier. It says, taking that string, I'm going to insert into it a carriage return, or this \n, in place of each one of those pieces. And that's just going to print things out in a nicer manner for us. I think we're ready to try this out. So I'm going to create a little database of students. And let me just go to my computer and set that up. So if I load this into my system, it prints out a set of things. And now let's see why it printed that out. I'm going to create some undergraduates. I'm going to create a couple of graduate students. I'm then going to create one of these grade books. And I'm going to add the students into that grade book. And notice I'm adding them in arbitrary order. That doesn't matter because things like the ID number are going to help us sort out who they are. Having done that, I can add some grades. And what I did is I added in grades for each one of these students, and then I just asked to print out a grade report. And it prints out that sequence that you saw there. Nicely set up because those carriage returns don't print it as one huge long string, but print each entry, if you like, on a different line. Now that I've done that, I could go in and add some more grades. And I'm going to just do that here, add in some additional grades. And if I do that, I can again check to see what happens if I sorry, I just want to set this up. What happens if I then print that out? And so if I load that into my system, nice. It's updated the grades to have the pieces I wanted inside of there. The point you should take away from this is that I'm now dealing with this database, this structure, without having to know the internal details. I don't know in what order are the students entered. I don't know that in fact the grades are stored as a list. I can simply say use add grade to add a grade associated with a student. I can then use things like sorted to simply figure out how to resort them so that they'll come out in an appropriate order, and then I can print out the appropriate information. And also notice this class has within it a large number of other class instances. That's perfect, because if I change the behavior of those class instances, it won't change the behavior of the grade book. Now, if I wanted to get out, for example, all the students in a class, I could do that by doing what I show right here. And in fact, I should do it that way. I'm going to just show you an example of that. If I say for S in 600 all students, let me print out S. It nicely prints out a list of the names of the students there. It's exactly what I'd like, sorted by ID number, which is perfect. Now, why didn't I just do for S in 600 dot students? I know that that's the representation I'm using. I could do it. In fact, if I typed it, it would give me out basically the same kind of thing. But this violates that data hiding aspect of an object. It exposes the internal representation. And I want to come back and remind you of this idea that I don't want to do that. Having built this system, I want to isolate from the user the internal representation. And as a consequence, if I were to change how I want to represent a gradebook, I should only need to change the methods within that object, not any external procedures that use it. So in that case, this would still work, but this would not if I were to change that internal representation. Just a reminder of a good, clean way to try and build your hierarchy. So what we see here is that this nicely separates the collection of data from the use of the data. I could start now computing statistics on how students are performing in my class. I can add students to my class. If I needed to, I could drop a student from the class. Because the access is through methods associated with that gradebook object, I've got this nice separation, and I'm going to try and be consistent of only using those methods to get at the internal data. There is one problem left with this, which is the thing I'm going to fix in the last portion of this lecture. Right now, this version is inefficient. To get a list of all the students, I create a copy of the internal list. That's nice. It lets me manipulate things without changing the internal structure. And if I have a class of only 20 or 30 or even a couple of hundred students, not a big deal. But in a MOOC like this, with 100,000 students, I don't want to always be generating a list 100,000 long before I do something with it. And I want to see how I might change things to have efficiency while preserving the performance that I've seen so far.